So hello my elders and welcome back to my new topic, and let me inform you that my today's topic is a question that is of JEE Mains 2019, and today's video is a requested video. Means someone had requested me to solve this question. This question we have, actually it is very long question written. So it is from JEE Mains 2019. So today we are going to solve this question. So now the question is that two blocks A and B of masses MA equals to 1 kg and MB equals to 3 kg. Masses, we have two blocks, we have A and B, where mass of A is 1 kg and that mass of B is 3 kg. Now are kept on the table as shown in the figure. Means those two blocks are kept on the table like this, in this set. Means just like A is put over B and B is put over table. Now here in figure we can see any external forces acting over B. Now the coefficient of friction between A and B is 0.2. Means this between A and block B, which coefficient of friction is acting, that is 0.2. Now and the surface of the table is also 0.2. Means what we can say, and between B and the surface of the table is also 0.2. Means which friction coefficient we have? Coefficient of friction between the block B and the table, that is also 0.2. Now the maximum force F, now we have after this that maximum force F that can be applied on B horizontally so that the block A does not slide over the block B, is, now here options have been given. Means if we apply any external force F over B, but its magnitude should be minimum so that A will not slide from B, A will not slide from B, it will not fall from B, it will maintain its position. So this, what magnitude of that minimum force, maximum force is, what is magnitude of that maximum external force that we have? We have in tech G equals to 10 meters per second square. Means we have to take acceleration due to gravity as 10 meters per second square. Now options have been given. A is 12 newtons, B is 16 newtons, C is 8 newtons and D is 14 newtons. So this we have to solve. So now from here we can begin our solution. So first, we have to find the force, maximum force. So let me inform you. First, leave the maximum force. First, find out the acceleration. We can write a formula for acceleration for this blocks, for the whole system, for entire system. So acceleration formula, what is it? F net means net force acting over system divided by total mass. Total mass we have. Acceleration formula, F net divided by total mass of entire system. This we have. Now to this in another way we can write, which is equals to, now here we can see that if such will apply any force, external force, so it will first of all come in motion. So after its motion, any friction will be acting between the two blocks and the surface, between block B and the surface, any frictional force will be acting. So here net force can be said as this F minus this frictional force, so which is equals to, so now this we can write, so A equals to F minus this frictional force F divided by M in total. Means mass of A plus mass of B. So MA plus MB. This we can write. Of course, this we can write. Acceleration of this system is F minus F divided by MA plus MB. This we can write. Of course, this we can write. Now, here what we can see, only one very simple method is to F, in a different manner. How we can write? Just like I give you example, this frictional force, frictional force, it is, can it be written as mu? Mu, of course, it will be coefficient of friction. Now, MA plus MB times G, can it be written such? Of course it will be written such, because that is the magnitude of friction, because friction equals to mu times the mg or mu times the n, where n magnitude is same as mg. So here total mass we are taking, so Ma plus mb, because that is the total mass of the entire system. So now at the place of this f, okay, this f in this formula, just put this equation. This equation we can put, of course we can put. So what we can write, A equals to this f, okay, external force which we are applying, minus this mu ma plus m of b, mass of B, times G divided by, now total mass ma plus mb, this we have, of course, ma plus mb. So much we solved. Now only some values we have to put. Now acceleration value we don't have. Already we haven't been given what will be the further acceleration of this system. So let it remain such. Force magnitude we ourselves have to find. So let it remain such. Force F as it is, F just write. Okay, now minus symbol is minus, just write. Now mu value what is given, both 0.2, because between B and surface 0.2, so minus 0.2. Ma plus mb, what is ma? 1. What is mb? 3. So 1 plus 3 times g value what we have to take, 10 meters per second square, so times 10 divided by ma plus mb. M is 1, MB is 3 kg, so 1 plus 3. This we have. Now F finally acceleration is F minus 0.2 times 1 plus 3 times 10 divided by 1 plus 3. This we have to, this will solve. So 1 plus 3 is 4. Now here only 4. Now what we can see after solving this, now 4 into 0.2 into 10. Okay, here we can write it. So its value will be 8. Of course, it's okay, to this we can solve. So 0.2 into 4 into 10 is 8. Okay. So 8, because 0.2 into 4 is 0.8, we know 0.8 into 10 is 8. So 8 divided by, now, okay, sorry, F, here F is also, so F minus 8, now divided by 4, okay, divided by 4, because 1 plus 3 is 4. Now here what we have, so finally what we are getting, that acceleration is F minus 8 divided by 4. This is further the acceleration of the entire system. Now we have to find out the force on this system, maximum external force that can be applied on this system, so that the block A does not slide from the block B. This we have. Now only this little formula, just like we can note, you can also note on copy, that one formula we have got out for this, A equals to F minus 8 divided by 4. This formula is very important and it will be helpful in solving the question. And then now let me erase it. Okay, so from here let me erase it, and now only using this formula, okay, some more concepts can be used, and we can easily, it is very easy question, so we can easily find out that what is, okay, the total force, maximum force that can be exerted. So if you have noted this formula, I am erasing it. A equals to F minus A divided by 4. Okay. Now let us begin once again. So what formula we had? E equals to F minus 8 divided by 4. This was our formula, equals to F minus 8 divided by 4. Now using this formula, only first let us discuss once more concept, that just like any frictional force will be acting. Okay, now here imagine that when this external force F will be acting in this direction, so what will happen, that block A, okay, it is given block A does, okay, so as we know in question it was given that block A does not slip from the block B, but even then if it does not slip, then also it will move from its position little. So wherever it will move here, then any frictional here, frictional force here will act. So any magnitude of F2, okay, just like that last time frictional force F we had taken, this time F2 let us take. So this time which will be acting between A and B, that will be F2. So F2 what we can write? F2 is equals to, now this is also a force, and according to the Newton's second law of motion, force equals to mass times acceleration. Okay, so mass means only mass of A we have to put, because here this frictional force is acting, okay, on A from B. Okay, this is acting, so on which, on A, so on the mass A, so this we have F2 equals to mass A times A. Now this is any frictional force. To frictional force we can write is equals to in a different manner, that is now mu, okay, mu we can take MA times A, okay, means mu and times N, where, okay, this we have, sorry, here G will be, Okay, this is G. Means mu times n, where n value is MAG. Means here normal contact force on block of mass MA we have to take. Means on block A we have to take. Okay, this is for frictional force on this block. So mu MA times G. This we have. So finally, according to this, only what we have to do. Now here according to this we can write. Now let it go anymore. So F2 we don't have to write. MA equals to mu MA times G. Now here only what we can do, that here what we can do, that is this MA and this MA can be cancelled. Of course it can be cancelled. MA cancelled. Okay, each in one times. So acceleration, what we got? Acceleration is mu G. Mu magnitude, what we have between A and B, what is coefficient of friction? That is 0.2. Okay, G value what we have to take? 10 meter per second square. So into 10. Now 0.2 into 10 is 2. Okay, so 2 meters per second square. Now acceleration, finally we got that acceleration of the system is 2 meters per second square. Now acceleration is 2 meters per second square. Now one formula of acceleration already we have noted. So according to this formula, so at the place of this A, can we put 2? Of course we can put, because its value is same as 2. So let us try to put 2. So 2 will put at the place of A. So 2 equals to F we had, as we don't know value. Now we have to find out minus 8 divided by 4. So finally 2 equals to F minus 8 divided by 4. Cross multiplication we can do. So finally implies that cross multiplication, and F minus 8 equals to 8. 4 into 2 is 8. This we have. So F minus 8 equals to 8 implies that F minus 8. Now this 8 can also come here. So minus 8. F minus 8 equals to 0. Can we write such? Then F minus 16, minus 8 is minus 16. So F minus 16 equals to 0. Now this only minus 16 will go that side. So what we'll get? So okay, minus 16 will become positive. So F, now here symbol will come here. So F equals to 16 newtons. Because F minus 16 equals to 0, to this minus 16 will send this side. So here it was negative, here it will be positive. So now this equal sign will come here. So F equals to 16 newtons. So here in options we have 12 newtons, 16 newtons, 8 newtons and 40 newtons. Where F value we have got the maximum value of F such that it can be exerted over block B and A will not slip from B. So here 16 newtons is coming. Of course it is coming. Means the B option is correct. Okay, so here finally we can see that in this question the option B is correct, where option B is 16 newtons. So the answer is option B, that is 16 newtons. So this was my today's topic. Thank you.